So understood? Shall we jump to program? What do you think? Will program be complex, or how we can implement the program which we can solve in a quick way? What do you think? By using Python, can we write it in efficiently, or you think that the Python syntax might not be suitable to write such a programs? So whatever the understanding which we have developed, this we have to convert into a program. So in any quick, I mean to say any quick logic, rough logic where you can suggest, like we can go through that and then we can write. So I'm just loading my PyCharm. Share a screen once it opens. See, for Python, what I'll do is we'll not write a program to construct the tree. So that's not the purpose of algorithm. The purpose of algorithm is to arrive at optimal cost of binary tree. So this, once we write a program to traverse across these numbers, use private computer and arrive at 26, that's enough for us. So this noting this 2, that can be done very efficiently. So what I'll do is I'll write a program for coming to this number 26. Okay, shall we jump to writing program, or you need any explanation in this figure? Okay, so let us write a program. Okay, just let me know one last time. I hope you understood this. How we have come to this 26 and what we have been doing this. Shall we move to program? I don't find any responses. Shall we move to program? Okay, so let me. Do you see my PyCharm screen? Okay. So let us write the program for this. So we'll have two lists called as keys and frequency, which will store the keys and the frequencies of my input. Okay, so we will first implement this, and later on you can optimize the way you want. So let me copy the values from the input which we have seen. If everything goes fine, we should get output as, that was the input from the earlier screen. So the keys are 10, 12, 16, 21. So for us, they don't matter much. What matters to all our algorithm works on this frequency. These are the actual inputs to my program. Okay, so this become the input. So now, if you consider an algorithm approach, what was more important apart from input? What other data structure which helped us in storing the values and using them whenever we needed? What was that data structure? The cost table. If you look at our approach, every algorithm or most of our algorithm dependent was on that table. where it had 0, 0. It had a row and column. Now, in Python, if you recall our memoization program for Fibonacci, or if you recall our some other programs, wherever I had a 2D matrix, we saw that we can use dictionaries as an efficient method to store these values 0, 1, 1, 2, 1, 3, and all that. So since I'm not traversing those values based on any specific pattern, I will prefer to store the computed values in a dictionary. Fine. So instead of defining a 2 by 2 2D list of lists, I will define a dictionary in which each key will be a tuple. For example, 0, comma 1 will be one tuple and associated computed value will be stored against that tuple value in the dictionary. Okay. So I'll define cost as a dictionary. And the purpose of this to store the computed values like tuple, for example, I comma j, which will be mapped with uh, the cost of PSP from node I to j. So that's how I'll use cost to store. So if I say 0, 0 means 0th node. Fine. So once I have a cost, what's the first thing I'll be doing here? Once I have a cost, what I'll do is I'll first initialize all initial values. So what I'll do is first I'll initialize all these values. This is fairly simple. So 1 1 means its frequency, 2 2 means its frequency, 3 3 means these values I can initialize that easily. This 4 2 6 3 that I'll initialize. Once I initialize that values, now I'll be computing this. See, you might have observed that to compute these values, it will always depend on these cells, the previous diagonal cells. To compute this, it depends on these values. To compute this, it always depends on the values which you have previously computed. This, or some of these values. So what I need to do to implement this as a Python program, this I will be initializing. Fine. After that, I have to solve it for 0 1. I have to solve it for 1 2. I have to solve it for 2 3. So you can see that a size of this window, a window like window covering two elements, is just moving from starting to end. This is the second moment, and then the third moment. This is one process. After that, what I'm doing when I'm at this row, when I'm at this row, what I'm doing is I'm considering a window of three elements and it just moves from this to this. And finally, I have a window which covers all the elements. So I will take this as a base and then I'll try to write a for loop for this one. Okay. So first I'll initialize this. And whenever I start solving for this two, what I have been doing, I need to take sum of frequencies. This I can do. By using the slice operation, I can take some of these operations 1 2 or 2 6 or 6 3. This I can take some. So slice with help of slicing operation, I can efficiently cut through. I can do a sum of this. What is important for me is to get this minimum. So I need to get this minimum. This I can easily get from the data structures. This is what I need to do. If I want to find minimum, I need to compute these values from previously stored arrays. So we will do that. Let us see one thing. So given this graph, let me see how I can write this minimum thing here. Okay. So in general, can I define this as this way? In general, if I say I want a cost for I to j, if I want to find cost of I to j, what I am doing? Sum of sum of frequencies of I to j. This is what I am doing, that plus I am doing minimum of plus I am doing minimum of all operations. So what will be minimum? If I say ij, the some frequency I am getting. How can I generically define what will be the values in that? So if I say minimum in this, what I am doing is I am trying to make one element of this as a root, and I am taking the cost of that. If I make first element of j, then I need to take cost of remaining elements. If I make second element of this series I to j as a cost, I need to take sum of cost of the possible subtrees. So what I'll do is, let us do one thing. If I make I as a root, see, I need to find out from I to j. I hope now this should be visible. If I make I as a root, if I make the first node in this as a root, if I make a first node in this root, for example, here I have made a 10 as a root. What was the cost 16 I am arriving at? This 16 is a cost of 1, 3. So if I make first node as a root, I need to make cost of I plus 1 to j. So this is result of making first node as root. Fine. After first node, when I make second node as a root node, when I make a second node as a root node, what are the possible cost I have? If I make second node, if I make a second as a root node, it would be cost of let us say I2 from I to what do you think? How can I do that? If I make second node, second node means it could be I plus 1. So first node means I, right? If I make I plus 1 as a root node, then the cost of first node I plus the cost of the next subtree, which will be cost of I plus 2 to j. And this is a result of making second node as root. So if I write it in this form, second node. What is second node then? Second node is I plus 1. Right? So on, if I make it for third node, if I make it for third node, means in left side what nodes I'll have? From I to I plus 2, from I2 to, I don't think I plus 2. I have made I plus 1 as a node, then I need to make I plus 2 as a node. If I make I plus 2 as a node, then from left I have I2 1, on right I have I plus 3 to j, I plus 3 to j, and this will be the cost for making third node, which is I plus 2, which is as a root. I hope you're getting this. I just highlight them in a red color. And this I'll make it as red color. So on, this process will continue. So on, this process will continue till when? What will be the last node to consider for this? So on, this will continue, I plus 1, I plus 2, but at some point, you have to make, at some point, you have to make last node as a root. I mean, this 21. So you made this, you want to check cost. You made this, you want to check cost. You made this, you want to check cost. At some stage, you will make the last node as a root, and all your left side will be a one subtree. So at that case, what will be the cost here? Then after this, it will be I2, from I2 end means j minus 1. It would be from I2 j minus 1. If I make the last j, if I make this j as root node, it will be the only cost, and this will be the result of making last node. Last node means j as a root. So this will be result of first node. Okay, are you getting that? So here I could be having some values. Then in the end, I'll come to this position. So in your algorithm, I can take this sum. So I need to generate this values to this. So this value I can take easily, this value I can take, but this intermediate values you have to generate, and from this all you have to find out the minimum one. Fine. It might seem to you heavy. I think it might seem to you heavy, but this the logic where we can write. Now slowly this logic will start becoming clear to you when we write the program. Fine. So let us continue back to PyCharm, and let me write. So you want this be there. Okay, let me share my PyCharm window. Okay, so cost is done. Let me do first initialization. So initialization means what I do for I in range. I'll take it for length of keys. Length of keys. What I need to do is cost of I comma I is equal to 0, not 0. What it is? Frequency. So where do I get the frequency? From the list frequency of I. This will just give me, it will let me initialize all the costs of node, the initial 0, 0 and 0, 0. Right? Okay. So after that, now what I'll do is I'll define the uh, size of input I am every time I'm working for. So initial size. So if I start here at 0, and if I want to take this window of 2 2, this one, the second and third, that's the only thing I am. So for 0 values I've already initialized. Now the next step is to compute it for size 2, size 2, and then it's so if here, since it is 0 indexed, since our structures and containers here are 0 index, 0 plus 1, 0 plus 1 means it creates a size of 2, 0 to 1. So here the size value should be 1. Our list, our containers, I'll call our containers are 0 indexed. Containers are 0 index. That's why the size will look like 1. Okay, you might confuse the size has to be 2, but since our indexing are starting from 0, I'll keep size as 1. So 0 plus 1, 0. That's how we are going it, from 0 plus 1. Okay, so now we can write. Now tell me, the program which we are writing, how long we have been repeating it? We are starting with one diagonal cell of that matrix, and I'm continuing this value till what point? Till what point I'm trying to repeat my algorithm? I am trying to repeat my algorithm till, see, I'm starting with these nodes 4, 2, 3. My algorithm stops when I compute this corner value. I mean, I'm computing value for 0, 0, 1, 1, 2, 2, and 3, 3, then 0, 1, then 1, 2, then 2, 3. Then I'm computing it for 0, 3. The moment I compute value for 0, 3, once I'm done with computing value for 0, 3, that marks the end of my algorithm. Fine. So based on that, I'll put a while loop. Okay. Let me switch back to HR window. Okay. So what we'll do is I'll write a while loop. Now, since we are using a dictionary here, I need to repeat my while loop till I have a value for a key 0, 3. So in my case, it is 0, 3 because I have 0 to 4. But what I'll do is, instead of hard coding it as 0, 3, I'll hard code in terms of the length of this keys. So while cost of in this dictionary, or what I'll do, cost dot get the value, cost dot get, give a tuple. What the tuple? The tuple is 0 comma length of keys minus 1. So whenever I take get, and if I do not have this value, I'll always return a default value minus 1. So as long as this one 0 to length of minus 1 keeps on returning minus 1, means I have not yet set any value for the 0 to the end index. As long as it returns me minus 1, I'll keep on continuing my loop. The moment I compute this value for 0 to length of keys is 4 minus 1, 0 to 3. Moment I compute the values for this key, I will no longer get minus 1. So this is a dictionary. I hope you recall. Dictionary.get a key and a default value. What this default value does, it returns a value if there is no value for this key. The moment I set, it will not return minus 1, and this condition will be false, and I'll be coming out of loop. So that would mark the end of that. And each time I do go inside this, what I have to do is I have to iterate across all this, right? I have to iterate for size of 1, size of 2, and all that. So initially, when size is 1, I need to move this window from starting to end, and I need to work for all elements. So, okay, let me write a for loop. For I in range, for I in range, here I have to start from 0, and I need to go till length of keys minus size, right? Why I'm saying length of key minus size? See, I'll start with 0. If I say this is a two size window I'm moving, this is where I move it, then next time it moves to this, and next time it moves to this. So long my I will be at 10, 12, and 16. It will not be at 21, because if I do 21 plus, I am exceeding the array bounds. So I am just moving. For example, if it is 3, the initial value is 10. Next time when this window moves, it only moves to till this. I don't want it to move to 16, because I don't have any extra value here. That's why I've said length of keys minus size. So I am starting at 0. So when you're starting at 0, what we'll do is we'll find a list called as min list, and inside this min list we'll add these values. What values? The cost computations which I am doing, right? So I need to find the cost when first node is wrote, the cost when second node is wrote, the cost when third node is wrote. That values I'll be putting in that. So let us do one thing. So the one thing which I can easily do, the first list dot append. What is always important? The always important is what if I make first node as a root, and what if I make a last node as a root? That is easy to do that, right? So one more last time I'll switch and I'll show you what I want to say. So this is easy. I'll just do this one first. I'll add into list this value and I'll add into list this value. So then after that I'll compute this intermediate values and then I'll add that, because I feel that these are trivial. This is what we can easily do that. Cost of one. This I need to figure out because I need to properly iterate from, I need to select one variable such k so that it becomes I to k, then k plus 1 to this. Then I to k plus 1, then the k keeps on incrementing. So I plus 1, I plus 1. You can see this increment, I plus 1. Here it would be I plus 2, here it would be I plus 4, I plus 3, I plus 5. So on it will come to this point. So this values I'll set. So going back to PyCharm window, so min dot list append, the first thing I'll append is the first the root values settings. So it should be, what will be the first? The first means I plus 1 till j. I plus 1 till j. Let me copy paste this thing for you so that you can understand this. Let me copy paste and bring these things in PyCharm window. So this is what I wrote there. This just I'm bringing it here. This is what I wrote there, right? So the first thing I want to add is this I plus 1 to j. So cost of a key with value I plus 1 to j. So in my case, what is j? What will be the j? The max value that I can move. So it would be I plus, what would be I plus size. Okay. After that, I will add this last one, I to j minus 1. If I add I to j minus 1, I to j minus 1 means, okay, I to j minus 1 means, say, okay, it's as simple as just writing I to j. J means the maximum value j can go is I minus size. Okay, so I minus size minus 1. So this is first node being root. This is last node being root. Now we'll add all intermediate. Add all intermediate nodes as root elements. So here is little bit tricky. I think if we can figure out the syntax here, that should be fine. Okay, so intermediate means I might need one more loop such that I have a k in range. I need to move it in a proper range. This range should be varying in between I plus 1 to j. in between I plus 1 to j. J means here in my case it would be I plus size. I think I forget this. Okay, so this will be always exclusive. This will be exclusive. So I am just, it would be last. Means I am perfectly at this point. From this cost to the end. I'm writing loop for this values. So every time I get, I will be adding it to min list. Then, so what should I write here? Now it is k. Now here if it is k, what should I write here? Append cost from two values I need to do. Here now it will be sum of two cost values, right? Because now I am at the mid, so here all the possibilities are two subtrees. The first one will be from I to k minus 1, and next will be k plus, if it is k minus 1, here it would be k plus 1. K plus 1 to the j. In my case, it is I plus 1, I plus size. This will keep on adding that. And once it is done, now I will add the final cost of the tree for which we are computing, which is I to I plus size. So for each window of 2, the initial window of 1, then initial window of 2, then so on. Now the final cost of this can be written as sum. I want sum of frequencies, right? The sum of frequency from this list. I can write a proper slice. I to I plus size plus 1, because this is exclusive. This index is exclusive. Sum plus, now I will take min. I'll use the standard minimum from this min list. From this min list, automatically I'll get the cost which I'm interested in. And once I am done with this, I'll increase the size of window. Size plus equal to 1. Okay. Once this is done, if I want to print the cost of last cell, what I need to do is just print the cost of tuple. What is the tuple? 0, 2. Or I'll do one thing. Cost dot get. I think I can also print direct cost of 0, 2. What was that? Length of keys minus 1. This value will include the value for my program. So now, if I want to run this for this, let me, okay. If I want to run this program, what's the output we are expecting for this? Okay. Let me see, let me run this. Run. Okay. Is the value which is what we have computed for? Yes, it is 26. Any other example you have? We can quickly test. Any other example? Can you quickly find any other example? I want to just test it somewhere. Or let me search on Google. OBST examples. I'm searching on Google if I can find any good. Let me know if someone finds a good example where if you have the computed cost in both, apart from what example we saw. Mhm. Anyone getting a good example of OBST where I want to test? Okay. Mm, okay, so let me take it for this example. So I have a piece 1, 2, 3, 4 and frequencies 1, 2, 3, 1, 2, 4 and 3. And as per the example, they are saying it should be 17, I guess. They're saying the output should be the 17. 17, they are claiming it is optimal binary search tree. Let me search and see if I get this value. Okay, so this is example. This is a standard example. I just took it from some university site, some university of some site. Okay, so for these keys and these frequencies, they are claiming it is 17 or off. Our output is also producing the output as 17. Okay, so I hope this is working and it is working for this. You can try it for multiple cases or you can figure out small samples and you can try it manually and then you can figure out what exactly output I'm getting. Okay, so almost 10 minutes exceeded we have. Can you tell me, have you understood the program? How many have understood? Instead of asking, have you understood? How many have you understood the program? Or you want to go through the recording and then see what exactly working, or you want this program, or you want to debug that? Let me know, Ajit, because based on your response, I'll decide next strategy and we can end the lecture. Have you understood the program? Yeah, this OBST is no doubt it's a bit complex, but I think whatever we have done, this should be of this if it runs for n and n, the total cost complexity of this will be n cube, and that's the optimal one by using dynamic. Whatever the approach which we is called bottom up approach. Okay, can you comment? Have you understood the program? Have you understood? You want me to share program? What is that? You're already exceeding that. Respond. Can you respond? Can you respond? Okay. Okay. So yeah, I'll share the program. I'll put it in the repository. You can directly go to that. Go to the repository which I've been sharing. You should get this program. Gurnath has a question. The key of cost dict is tuple, but you have used cost. I did not get. See, I think a dictionary keys can also be accessed. I'll just show you how it is. A dictionary keys can also be accessed by that terms. I think I hope you let me quickly show you. Okay, see, if I have a dictionary, for example, sample. I'm saying sample is equal to I'm saying dictionary. Say 1 mapped with value 10, 2 mapped with value 20, and 3 mapped with value minus 30. Okay, now if I say sample dot get, if I say 1, you are getting 10, right? The same I can also say sample 1, I'm getting 10. If I say sample 3, sample 2, I'll get minus. What do you mean by sample 2? It is not index 2. Remember, it is not index 2. If you consider index 2, it is index 0, 1, 2. You should have getting minus 30. It is not. Dictionaries can also be accessed by using index, where the index itself acts as a key. Index acts as a key. I hope you're getting this. For example, if I say 3, P3, not index 3. Do you see any index 3 in this? No, there is no index 3. Likewise, if you say 4, you should get error, key error. What it is saying, there is no key with key 4. So now, if you set sample of 4 is equal to minus 40, what you're doing, you're actually setting a value for key with sample 4 as 40. This is working of dictionary. I think now it should make you clear. Now I think you should understand. But why I am using this? You might be thinking it is a list or something. He is doing that. Okay, it is dictionary. Dictionary with a tuple this as a key. Okay, so I'll share the program. Go through it. If you still don't understand, let me know. Yeah, I agree that this is a complex at first bit, but I've tried my best to explain this program and this. Let us see. You work it for few programs, and at the same time, you can also the best thing to learn the logic is to debug that. So you start debugging this. See, if I go on X7, it will automatically keep on computing the values. You can see how the values are being computed. 1, 2, 2, 3. Then you will have 0, 2. Somewhere it will end at 26, 17 for this. So try it for our earlier input. Compare it with the table which I created. Okay, so I won't take much time. I hope you have understood. I'll be sharing the program in the same repository, and the rest discussion will continue in the Telegram group. So by afternoon, let me know have you understood. Try it for different case. And from you, what I want is I want you a logic to get the tree. So here we are not stored the root, but we can equally store root by taking one more dictionary called as roots, and there I can just keep on storing the roots. Okay, the complexity of this program will be of n cube. Why n cube? While almost you are going for n times. This for almost n times, and internally almost n times. So roughly the complexity goes to O of n cube. Fine. So for any questions, let us discuss that in Telegram group. Okay. So I'll also share the recording of this program. I think I've started recording it in between, but still I'll share that. Okay. So that's it. So I'm ending this lecture. Let us meet in next lecture.